Yep, you're welcome. Alright, so polynomial basics is what we're looking at. So remember, folks, we are not done, right? Even though we have taken our benchmark, right, and we took our circles quiz, we're kind of getting into a different kind of topic. We will still be quizzing, right? There are still grades for this class, and so you still, need to be, students in this class. I know I've been away too and stuff like that. We were watching videos and things, but we are doing stuff. So please do follow along.
You know what was it? They watched it.
They did?
Yeah.
You guys like Stand and Deliver? It's a good movie. I thought it was good. I mean, it's a little dated with the dress and the car. I mean, it was a little old, but still, I like the story.
Mr. Witt, though, I like to point out that this is a whole lot of swearing in it. It says it's rated PG on the back.
I know. Well, you got to understand that PG movies. There was no PG-13 movies for since mid '80s. I want to say is when they started doing that. So a lot of older PG movies actually probably should have been PG-13 by today's standards. If you watch The Goonies, there's a ton of swearing in The Goonies. Ton. And that's PG as well. Alright, anyway. That's right. Hey, Kimo! What's calculus?
I'm the finger man.
I'm the finger man.
I'm the finger man too.
Yeah. I can count by nines. That's what he says in the movie. Alright. First thing we're going to make sure we have down here. Adding and subtracting polynomials.
What's a polynomial?
Okay. Polynomials, right? So what makes a polynomial a polynomial? Well, that's a very good question. So a polynomial, right, is basically numbers.
A poly and a nomial?
Okay. Letters, or variables, I should say.
And words?
Okay. Or a sum/product of both. Well, because I wasn't really going to include the definition of a polynomial, but since Jordan asked. Okay, so what makes a polynomial? It's numbers, right? So the number 2, that's a polynomial, right? Okay. It's variables, x is a polynomial. But then x plus 3, right? X is a sum or product of numbers and variables. Or 3x plus 5, y. Gentlemen, you should have paper out, right? We're ready to go? All right, we're learning things now, okay? Or a product, sum or product of both, okay? And what is not a polynomial? This, for example, x over y, not a polynomial, okay? Because it's x divided by y, so that would not be a polynomial, okay? And we're not going to be dealing with those. Not at least for this part. We might get into those later, we'll see. Okay? So, to add or subtract polynomials, what's the key thing to remember? You're just combining terms. Okay, but as we saw from the warm-up, that can be kind of tricky, because sometimes when we look at things, right, we think that they aren't when they really are. Okay, or sometimes we think that they are when they really are not okay, so we have to be careful. So to be like terms, what did we determine you had to find in order for things to be like terms? What had to be the same? Same exponents and same variables. That's exactly right. Same exponents, same variables.
That's your final warning. One more time, you're out of here.
Okay, let's get.
All right, let's go. I don't know what you're saying. We're not done. Take a note. Take a note.
So let's look at this first example here. Okay, 3x plus 7 equals, or plus 2x minus 10, right? And we want to combine the like terms there. Now, for whatever reason, there are parentheses around this. All right. So, yeah, Connie, if you want to move up, go ahead. Okay.
There's 2 logical reasons on why there's parentheses there.
All right. The parentheses don't really do anything for us right now. Okay. Normally when we have parentheses, right, we want to see is there anything in front of it, but there's not, and there's not anything in front here to really worry about because just the plus sign there, okay?
Well, because there's like, one is like big X could have a value and then you have to multiply it.
Right, exactly right, yep.
And second, you didn't say, you put them there.
Right, I put them there, exactly right, because sometimes we can have...
Adding.
Right, we're adding, right? You see the plus sign between the two parentheses there. Ooh, Colin, Mr. Rumpf wishes to see you. Okay, so we want to combine these. We're going to add them. Okay, so the 3x, okay, that's going to add with what over here? The 2x, and that is going to create 5. Very good. Yeah, 3 plus 2 makes 5x. Okay, good. So we kind of took care of those. I'm going to actually cross those out just so I don't like accidentally count them again or something. You don't have to do that, but I think it's just helpful. And then are there any other like terms here? 7 and, yeah, we want to count that as like a negative 10. Even though it is a 10, it's really minus 10, so we're going to count that as like a negative 10. So 7 plus negative 10 is, yes, very good, negative 3. So you could write that as either plus negative 3 or 5x minus 3. Yeah, either one is acceptable. Okay. Very good. All right, let's try another one here. All right, let's do 9r, and for whatever reason, sometimes, you know, we just like change up the variables here, right? It's not always going to be x's. Sometimes we have like r's or p's or t's. T's are kind of mean, though, because they look like addition signs. Okay, and then negative 2r squared minus 8r cubed plus 9r. Okay, so again, here we're adding two polynomials. Okay, more specifically, we call this thing a trinomial. Why do you think we might call this thing a trinomial? There are 3 things here, and that what is this thing? There are 3 as well, so it's a trinomial. What do you think we call this? There's only 2.
Donomial?
A binomial, meaning 2. Bi means 2, right? Like a bicycle, 2 wheels, okay?
And then would 4 be quadnomial?
Yeah, they I think they have like a quadrinomial, I guess you could call it like that, something like that. Yeah, after that you just start calling them polynomials, though. For whatever reason, we say trinomial, and then we just kind of start calling them polynomials. Basically, yes. It should be pretty much straight up review, yeah. We'll get into a little bit of multiplying, too. We're not going to do all adding and subtracting. We're going to do some multiplication here, too. So, all right, let's go to Melissa. So we've got a polynomial here. Oops, sorry. This is not supposed to be 9r squared, folks. I made a mistake. It should be 9r cubed. So if you want to make that square cubed, please make it a cubed. Okay. So 9r cubed. I'm sorry. That should be 9r cubed. All right. So Melissa, we're going to add these two things together. So first of all, let's look in here. Melissa, are there any like terms just in these 3 terms themselves? Like, are there any things you can combine just between these 3? Are there any like terms? Right here. No. Okay, very good. Right, they all have an R, but why don't they go together? They all have R, but what's different about those R's? Exponents or powers, yeah, good, okay. Same thing over here, right? All have R, but they're different exponents. Okay, so now we're going to look, but we're going to add these two things together. So the 9r cubed here, does that combine with anything over here? Yep, so it's a negative 8 or minus 8, right? So what's 9 plus negative 8 there?
1.
Yeah, it's just going to be a 1, right? Yeah, so 1r cubed, or if we just write r cubed, that's fine. Okay. Melissa, 11r. Does that combine with anything over here? 9. So 11 plus 9, that's going to give us 20r. And then the 5r squared, where does that go with, Melissa? The negative 2, very good. And that gives us 3r squared. Okay. Now, you can leave your answer in that order. However, I will say that traditionally we rewrite the order slightly here. We'll write r cubed and then what? Then the 3r squared and then the 20r, right? You write things in descending order of power. So highest power, then the next highest power, then the next highest power.
Why not ascending?
Sometimes they ask you to put it in an ascending order, but for the most part, it's descending order. Nah. Alright, let's try another one. Let's try another one here. Alright. 3x to the fourth minus 3x minus 3x minus 3x to the fourth. Okay? Alright, Jordan, one second. What's that?
Adding like terms.
So we're combining like terms again. Yep, that's right. But the thing is here, now we're subtracting. We have subtraction here in front of parentheses. So when you have a minus in front of the parentheses like that, what happens to the minus sign?
You multiply it by negative.
Yeah, it like distributes. It distributes through the parentheses here. So it's not just minus 3x, it's also going to be minus 3x to the fourth. So what you can do here, one thing I'm going to suggest is we kind of distribute, okay? And you know, sometimes there's different ways you can kind of think of it that way. You can make this plus and then just change this to a minus here and then a plus here. Like, so you make everything opposite. So you make this plus and then everything in the parentheses you just make opposite, and then you can combine like terms using addition now. Okay, so you distribute the minus, so the positive 3x became negative 3x, the minus 3x to the fourth became plus 3x to the fourth, and now you can just add them all together. So 3x to the fourth combines with the 3x to the fourth makes 6x to the fourth, right? And then negative 3x plus negative 3x is what? So plus negative 6x, or again, if you don't like that, you could write 6x to the fourth minus 6x, right? Either one of those two is fine there. Either one of those two is fine. Okay? One more like this, and then I'll have you guys try two on your own. And then we'll look at some multiplying. Excuse me. Look at some multiplying. Okay, so one more example here, and then I'll have you guys try some on your own. All right. Any questions so far? Any questions so far? We're all good? All right, moving on then. 5y cubed plus 4y to the fourth. 5y cubed plus 4y to the fourth minus the quantity y to the fourth minus 4y cubed. Okay, so kind of like, okay. So 5y cubed plus 4y to the fourth minus y to the fourth minus 4y cubed. All right. So let's go to some we haven't heard from yet. Come on now, Corey. All right. Well, so Corey, we have a polynomial here, right? Grouped with parentheses, minus another polynomial here, also grouped with parentheses there. Okay. There's a minus sign. That means we're subtracting these two polynomials. All right. So right now we have a 4y to the fourth, and we're going to subtract y to the fourth. All right. And that can be kind of a lot to keep track of. So if you want, you can change this minus to a plus, and then everything inside the parenthesis after it will just make it the opposite. So kind of like a same change or leave change, right? So we keep this the same, we change the sign here, and then we change all the signs in there to make it the opposite. Okay? So, Corey, 5y cubed, what does that combine with over here? 4y cubed, so what is that going to make? We're adding it though now, remember, adding. 9y cubed, good. Okay, so those are taken care of. And then what else can we combine? Anything else? The 4y to the fourth and the negative y to the fourth, those are actually like terms. They both have the same variable, y. They both have the same exponent, 4. So they do combine. So yes, very good. 3y to the fourth. Good job. Okay, let me give you guys two to try here. Okay, question. Sorry.
So at first I timed it, I don't know why, but I just timed like the 5 and the 4.
Okay, so yeah, we don't want to multiply here, right? Because we have addition, we have plus between those two, and we'll get to multiplication here in a second. Okay, so don't you worry, we'll get to that. All right, try these two here. 6m plus 3 minus the quantity 6m plus 2. Okay, and then I'll try this one. 3a squared plus 5a cubed minus 2, okay, plus 3a cubed minus a plus 4a squared. Okay? Just like that. So go ahead and give those two a try. I'll kind of come around and help as necessary here. Okay. I'll kind of come around and help as necessary. Close. So, 6m, but then plus negative 6m. How many m is that? Be 0m. So the m goes away. Remember, when you write an m, that actually means 1m, right? Just an m by itself really means 1m. So it would just be 1. So, yes. Both things kind of both.
I like this book a lot.
Yeah. Yes.
Like this for like him finding himself. Like,
Yep, so you have plus, and then,
he's like,
minus
he has a
6m,
thirst for like
minus 2.
knowledge, and he wants.
Minus sign distributes to both terms. So this was a positive 6m, you make it negative 6m. This was a positive 2, you make it negative
So
2.
he went to
You make them the opposite.
place where he was gonna find it, but he ended up like, learning stuff and trying to like not have a thirst for knowledge, but every time you learn something new, just like try to decompress the thirst. It like, yeah.
So basically, he is a nerdy vampire.
A what?
So he's like a vampire, but instead of sucking blood, he sucks knowledge.
I guess.
Close. So well, let me show you. We'll just go through it.
So then like, he like quit that place and like trying to find the pizza.
So, let's go ahead and try this here. Alright, we'll see. So, number 1, it says 6m plus 3 minus 6m plus 2. So, we're subtracting here, which means you want to distribute this minus sign, okay? So the minus sign is going to distribute to the 6m and to the 2, okay? And so again, we're going to do, so 6m plus 3, make kind of like leave change or same change, right? Instead of subtracting this quantity, we're going to add, and then we'll make this negative 6m, because it was positive, we'll make it negative, because we're distributing the minus. And then plus 2, again, we'll do the opposite, so plus negative 2. Okay? And now we combine like terms. 6m plus negative 6m, what does that make? Anybody? Yeah, 0, right? They cancel out. It's gone. So you can write a 0 there, you can just leave it blank, but they cancel out. And then 3 plus negative 2 is 1. So we get 0 plus 1, so the final answer is just 1. Just 1. In this case, the m's canceled, okay? The m's canceled. M terms canceled. Okay? So any questions on that one? That was a little bit funky.
It was just, because since it was like for the M, I just did the M plus an M, but like, I should change that M to 0 plus an M.
The idea is that, the m's did not get, well, they did get added together here, but it was a minus, right? And so this positive 6 had become negative 6 because we distributed the minus sign. So it became negative 6m, and then plus a negative 2, and so then the 6 plus negative 6, they cancel. It makes 0, right? So that's why I give it 0m, and then 3 plus negative 2 becomes 1. Just 1. Okay. All right. So Curtis, does that make some sense there? Okay. And then next one we'll look at here, so actually, well, Curtis, let's have you try this one here, Curtis. So 3a squared plus 5a cubed minus 2 plus 3a cubed minus a plus 4a squared. Can you see it okay back there, Curtis, right? Okay. So 3a squared, are there any like terms with 3a squared here? So careful, this is not 3a squared, that is a 3a, that's a 3 right there, if you can't read my handwriting. So I can zoom in a little bit more here, a skosh more. Yeah, there you go, 4. So 3, and it's the plus sign between them, so 3 plus 4 makes 7. A squared for us there. They combine together to make 7, okay? What about 5a cubed? Is there anything else like with that over here? 3a cubed, yep, and we're going to add those together. So 5a cubed plus 3a cubed is 8a cubed. Okay, is there anything like with the 2? No, so we're just going to rewrite that, minus 2. Is there anything like with the a? No, so we rewrite that. Okay, so there's kind of your answer there. Okay, now that's not in the normal descending order, but you can stop there. It didn't say to write it in descending order, so you can stop right there. Okay, 7a squared plus 8a cubed minus 2 minus a. Okay, questions on any of that?
What you said, 7a cubed?
7a squared, sorry, I might have said 7a cubed. So 7a squared plus 8a cubed minus 2 minus a. Okay? Thank you. Okay, questions on any of that? Not quite done yet. I also want to go over multiplying polynomials too. We're not going to talk about dividing. Dividing actually kind of makes things a little more complicated. We're going to worry about dividing later. Maybe we'll do that in a little unit or something like that at the end. But we're going to look at straight up multiplying. Thank you. Multiplying polynomials. Okay, yeah, they're here. So thank you. All right. There you go. Corey and Colin S. You are requested now in the attendance office. Okay, so Corey and Colin in the attendance office, please. All right. Multiplying polynomials. And we'll just do 4 problems here. Okay. We're covering kind of a lot today, but it's kind of simple stuff you've seen before, hopefully. All right. The first thing we're going to do is talk about multiplying a monomial. Okay, this is a monomial, right? This is kind of like one thing. It's 6x together. It's one product there. We're going to multiply a monomial times a polynomial. So here's like a polynomial of negative 10x plus 4. Okay, so this, yes, go ahead.
Is this like foil?
Close. Here, do we need to FOIL? No, we're not going to FOIL here, okay? And we'll talk about why in a second, okay?
Because it's not like, it doesn't have to be like another...
Right, you need to have like a plus, another binomial. A binomial times a binomial, that's FOIL. Here, we just have the 6, but I'm glad you remember that, Alex, that's good. So the 6x, it's one thing. It's all one product, 6x, and that's going to distribute to negative 10x, and it's going to distribute to the 4, right? We have multiplication, and then there's addition inside the parentheses here, so it gets distributed. The 6x gets distributed. Okay? So now I'm going to write this step out. You don't need to write this step out if you don't want to, but 6x times negative 10x is what we're going to do. So I'm actually going to write out 6x times negative 10x, and then add, right, plus 6x times 4. So again, all I did was I wrote out the distribution, right? I showed it here with like the little arches, right? That's what you're used to kind of seeing. The 6x multiplies to negative 10x. The 6x multiplies to the 4. And so we end up with 6x times negative 10x plus the 6x times 4. You don't have to write this step out if you don't want to, but it's just, you know, a little helpful sometimes. But now we're actually going to do the multiplication here. So 6x times negative 10x. What does that give us?
Negative 60.
Negative 60 x squared, right. The 6 and the negative 10 make negative 60. The x times x, well, that's just x squared, right? X times itself is x squared, like Alex said earlier, right? What do those exponents mean? An exponent means you're multiplying something by itself. So when I multiplied x times x, that simplifies to x squared. Okay? Plus, what's 6x times 4? 24x. That's right. And then there's your final answer. Okay, there's no like terms to combine or anything like that. We just finished the multiplication. All right. Questions on any of that?
Can you do that? Like the way we put it out, like x plus, times.
This?
Yeah.
And then this?
Yeah, because if we do that and then everything's in there, because if we do that in the test, like, that'd be...
Oh yeah, absolutely. That's fine. And if that helps you, so some people probably looked at this and could just do the 6x times the negative 10x right there in their head, and 6x times 4 in their head, and then write it out, and that's fine. And you'll get to that point too if that's not how comfortable you are. If you want to write this step out, though, that's not a bad idea if you think it'll help you. Yeah. But eventually you'll get to the point where you can just go right from here
And
to
we
there.
never changed it, a negative in our case to a positive, right?
No, because there's no, so for here, when we did that in, these problems, because there was, minus in front of a parenthesis, so we have to, distribute the minus sign. Here, the thing we're trying to distribute is just the 6x, so there's no need to worry about, changing signs or anything like that. Okay? So, all right. 4x cubed times 11 plus 3x squared. Let's try this one. Okay, 4x cubed times 11 plus 3x squared. Okay. Alright, so Kwanye, you want to do this one?
Sure.
Alright.
Okay. So I did 4x cubed times 11, which is 44x.
Okay, sorry, I'm going to write it out first, but that's fine. So 4x cubed times 11, and then plus 4x cubed times what else?
3x.
3x squared. Okay, and so you said when you multiplied 4x cubed into the 11, what'd you get?
44x cubed.
44x cubed, okay. And then when you multiplied 4x cubed times 3x squared, 12x to the 5th. Very good. 12x to the 5th. Yes, it's 3 plus 2. Remember, when you multiply numbers with exponents, you add the exponents. So x cubed, x squared is x to the 5th. You add those exponents. And there's your answer. Okay? Questions on any of that? We'll see some of those in our practice today, too. Alright, and then the last little thing is something that Alex already alluded to here, and that is FOIL, right? So,
Tinfoil?
tinfoil, right. Okay. Now let's stop and take a minute here, alright, about why this we use FOIL, but this we do not. We have to kind of appreciate the differences here. Here we multiplied a monomial, right, a single-term polynomial, times a binomial. Here again, monomial times binomial. Here, what are we multiplying together here? To what? Yeah, x plus 2 times x plus 3. These are binomials. We're multiplying two binomials together, right?
Yes.
Here it was just one monomial, a single thing, times 2. A single thing times 2. But here it's two things and two things. Now we want to use FOIL. Exactly right. Okay? So for those of you that are familiar with... So is anyone here not familiar with FOIL? That's okay. Anyone not familiar with FOIL? Okay. So FOIL is just an acronym, right, that we use to help us remember how to, or a mnemonic device, like Roy G. Biv or SOHCAHTOA, that helps us remember how to multiply two binomials together. Okay? So, FOIL, right, the F in FOIL stands for? Front. Okay, so what are the two things out front? X's. So x times x is x squared, right, plus, okay, the O stands for? Outer, or outside, so the x and the 3 are both on the outside, right? The x is the farthest to the left, 3 is the furthest right, so x times 3 is 3x. Okay, the I stands for inside, so 2 times x, 2x. And then L stands for last, so 2 times 3 is 6. Okay. Good. And then what? We're not quite done yet. We have some like terms, don't we? So we should combine those like terms. X squared plus 5x plus 6. Okay, now, FOIL is useful for when you're multiplying binomials, all right? But there are sometimes other situations where we might be multiplying a binomial times a trinomial, and that's a lot of work. But here's another method, too. Have you guys ever heard of the crab claw?
No.
So, the idea is that just like we did here with the 6x, right, where we distributed to the negative 10x into the 4, and here with the 4x cubed, we distributed to the 11 and to the 3x squared. We can also use the distributive property here, okay? It's just that each term here distributes to each term here. So in other words, x multiplies to the x, right, that was the first, and then x multiplies to the 3, that was the outside, right? But then also we have to multiply the 2 to the x, so that's inner, and then 2 times the 3, that's the last.
Oh my God.
And you end up with like a little crab claw, that's right, okay? Now, why is this useful? Because this technique works for any time you're multiplying polynomials. So for example, if I had a polynomial like this, and I wanted to multiply that with this, okay, can I use FOIL here? Does FOIL work?
No.
No, because you have a first, right? You do have an outer, you do have kind of an inner and a last, but you're like missing some like middle terms there. So how do you multiply something like this together? Well, you do x squared times 3x squared, x squared times 4x, x squared times minus 2. And then you do 2x times 3x squared, 2x times 4x, 2x times minus 2. And then you do 3 times 3x squared, 3 times 4x, 3 times the minus 2. And then you combine all those like terms together.
It looks like a wave.
Okay? Right, it's pretty crazy. Combine all those terms together, and that gives you what you know, the multiplication there. Obviously, we're not going to do a lot of these. They take a lot of work, right? And they're kind of like tedious. Okay? But that's how you do something like that. Okay?
How we don't do that?
All right, we're going to do one more here, and this one, it's not going to be as bad as the one you saw on the board there.
It's going to be worse.
Last one, and I'll get you guys started on your assignment. Okay, last one, and I'll have you start on your assignment. Okay? I like the crab claw method. I like this distributed method better because it's more generally useful. But you guys can use FOIL too if you want. That's fine, if that's more comfortable with for you. All right, Jason! All right, we're going to multiply these two polynomials here, Jason. So, do you like to use FOIL or FOIL? Okay, so then what are we going to get here when we multiply these two things together? Go for it. 2x times 5, so that gives us? That's okay. 2x times 5 gives us what? 10x. There you go. Okay? So that was the first. So then the outer, so that's going to give us what then? Negative 6 x squared. Very good. Okay, that was the outer. Okay, and then the inner is the next one. So negative 10. Plus 6x. Very good. Okay, do we have any like terms we can combine in here, Jason?
Yeah, we have
10x and 6x, and those are combined to make 16x. So you could say 16x minus 6x squared minus 10, which is fine. However, again, most of the time we write these in descending order. Somebody's going to be, it'll be negative 6x squared, right? It's a negative 6x squared. Then plus 16x is the positive 16x, and then minus 10. Okay? And there's our final answer there. Questions on any of that? All right.